A routine systemd update landed this week, and one part of it can let a local attacker add arbitrary groups to a logged-in user. That is not the kind of headline that spreads everywhere, but it is exactly the kind of update that deserves attention before you get lost in a long CVE list. This week's Linux security queue has three very different problems hiding in it. There is a local privilege escalation in systemd. There is a Debian WordPress advisory that includes remote code execution risk. And there is an Axios update that matters to Node.js services because a proxy rule can become a path into services that were supposed to stay internal. The mistake is treating those three things as though they all have the same urgency on every machine. They do not. A public WordPress site has a different threat model from a single user workstation. A backend service that fetches user-provided URLs has a different risk from a laptop that never runs Node. And a kernel patch may matter most because it is already packaged, ready to install, and waiting for the reboot that nobody scheduled. So this is not going to be a dramatic reading of every CVE number. It is a practical Linux security update. What matters, who needs to care, and what I would patch first on a real system. And there are two questions that matter more than any severity label. First, why can a local systemd issue outrank a much scarier looking kernel bulletin on a shared machine? Second, how can an HTTP client library turn a supposedly safe outbound proxy configuration into access to something internal? We will answer both. We will also look at the kernel update wave, an OpenSSL QUIC issue that is narrow but worth understanding, and one active exploitation warning that is not Linux native but absolutely matters if you self-host it on Linux. Before we zoom in, keep one idea in mind. The best patch order is based on exposure. Start with the vulnerability that matches the way your system is actually used. That is why the first story is systemd homed, and why its impact depends very much on who can log into the machine in the first place. The most important local issue in this week's Ubuntu updates is CVE 2026-16742. It affects systemd homed, which is the part of systemd designed to manage portable user home directories and their identity records. Canonical says that systemd homed did not properly verify the signature of a home record. In plain English, the mechanism that decides what groups belong to a logged-in user could be tricked into accepting information it should not trust. A local attacker could then add arbitrary system groups to that user and gain elevated privileges. This is not a remote, one-click compromise of every Ubuntu box. An attacker needs a local foothold first. But that is exactly why it matters on developer systems, shared workstations, university lab machines, CI runners, jump hosts, or anything with more than one person able to log in. Privilege escalation is what turns a limited user account into a much larger incident. There are two other systemd fixes in the same advisory. CVE 2026-15060 affects systemd machined on Ubuntu 26.04. and can allow a local attacker to terminate arbitrary processes through incorrect pull-kit authorization checks. CVE 2026-15059 affects systemd oomed, where malformed IPC requests can lead to arbitrary process termination. Those latter two are availability problems. The systemd home flaw is the one that can change the security boundary between user and administrator. So, if systemd homed is installed or active, this moves to the front of the queue. For Ubuntu, the fixed package versions are 259.5-0 Ubuntu 3.4 on 26.04, 255.4-1 Ubuntu 8.17 on 24.04, and 249.11-0 Ubuntu 3.22 on 22.04. You do not need to memorize that list. The point is to update through the normal security channel and verify the installed version afterwards. But this raises the first big prioritization question. If local access is required, why not leave this until after every internet-facing patch? Because on shared machines, local access is not a hypothetical. And the next story is the opposite case. A web application where exposure can begin from the outside. Now let's switch from a local trust boundary to a public application boundary. Debian published DSA 64271 for WordPress, tracking CVE 2026 64638. Debian's wording is deliberately broad but important. The affected package vulnerabilities could result in cross-site scripting, server-side request forgery, privilege escalation, or remote code execution. If you operate WordPress on a Debian server that is reachable from the internet, this is the update that can leap ahead of the systemd work. A public application is exposed to people who do not already have a user account on the host. That does not mean an attacker automatically gets root from a single WordPress bug. It means the initial door may be open to people you never invited in. For Debian 13, also known as Trixie, the fixed package version is 6.8.7 plus DFSG 10 plus deb13 U1. If you install WordPress from Debian packages, the job is to update that package and then verify that your running site is actually using it. And that second part is easy to miss. Plenty of WordPress deployments are not running the operating system package. They are copied into a web root by hand, managed by a hosting panel, packaged in a container image, or updated through a separate automation tool. In those cases, a clean apt update can give you a false sense of security, because the site serving traffic may be using a completely different code tree. The practical response is to list your public WordPress instances, identify their actual update path, install the vendor or distro fix, and check for anything unusual in administrative accounts, plugins, weblogs, and outbound requests if the site was unpatched while publicly exposed. There is another reason this advisory is useful as a patch priority example. It includes both browser-side and server-side possibilities. The server-side request forgery part matters because a public web application can sometimes be used as a stepping stone toward services that are not publicly accessible. And that is the perfect bridge to Axios. Unlike WordPress, Axios is not the application users see. It is a library developers quietly rely on to make HTTP requests. But when its proxy rules are wrong, that quiet library can become the path toward internal services. Axios is one of those dependencies that can be sitting underneath. A perfectly ordinary Node.js service without anyone thinking about it again. It makes HTTP requests. That sounds harmless until your service accepts a URL, follows a redirect, calls an internal API, or relies on a proxy policy to prevent access to private addresses. Ubuntu's USN 86381, published on 13th August, fixes several Axios problems. Two of them are especially relevant: CVE 2025 62718 and CVE 2026 42043. Both involve the way NOPROXY rules are applied. In the affected cases, an attacker may be able to bypass proxy restrictions and reach internal services, creating server-side request forgery risk. Here's the simple version. Imagine your backend fetches a URL on behalf of a user. You route outbound traffic through a proxy and you expect that policy to stop the service from reaching addresses that should be private. If the HTTP library decides a hostname or loopback address matches an exception incorrectly, the request can skip that expected boundary. This is not an Axios-only problem in the abstract. SSRF becomes serious because applications often have permissions and network reach that the person making the request does not. Internal dashboards, service metadata endpoints, private APIs, and management interfaces may all be more visible to the backend than to the outside world. The advisory also covers CVE 2026 40175 for header injection through prototype pollution, plus 2 prototype pollution issues that can influence response handling or outbound request configuration. On Ubuntu, the listed package fixes were delivered through Ubuntu Pro ESM apps at the time of the advisory, so verify your maintenance channel provides the patched package. The key question is not, do I have Node.js? It is, do any of my services use Axios to fetch or call destinations that an untrusted person can influence? If the answer is yes, this deserves a focused inventory and a proper regression test. And that leads to a different category of update, the kernel. It is easy to look at a large kernel bulletin and either panic or ignore it. The right response sits in the middle. Ubuntu released a broad set of kernel security packages on 13th August. The two notices most relevant here cover low latency, Oracle, Tegra, and OEM kernel builds across supported Ubuntu releases. The fixes touch a long list of areas: IPv4 and IPv6 networking, TCP, multipath TCP, NetFilter, SCTP, traffic control, drivers, and more. That list looks intimidating, but it does not mean every machine faces the same immediate exploit path. It also does not mean every CV in the list was first discovered this week. What changed this week is that Ubuntu published current packages for a broad set of kernel variants. And the update needs the one thing kernel updates always need: a reboot. By the way, I just checked our channel analytics, and about 82% of you watching right now are not subscribed yet. If these practical Linux security breakdowns help you decide what to patch and what can wait, hitting subscribe is the best free way to support the channel. For the kernel work, start by identifying which meta package your machines actually follow. Standard generic systems, low latency builds, cloud kernels, OEM kernels, and special hardware kernels can have different package names and update timing. If you use third-party modules for graphics, storage, endpoint protection, capture devices, or special networking, plan for the ABI update. Canonical warns that some third-party modules may need to be rebuilt or reinstalled. This is why I call the kernel wave a maintenance problem rather than a panic problem. The update is important, but the correct outcome is not install everything blindly at noon. It is a staged rollout. Apply the update, check the module status, reboot into the new kernel, validate the running version, and confirm your critical workload still works. So now we have a local privilege escalation priority, an internet-facing application priority, a backend SSRF priority, and a packaged kernel maintenance priority. Before we put them in a final order, there are two smaller but more specialized stories worth knowing, because one is about availability and the other is already in CISA's actively exploited catalog. CVE 2026. 14,456 is a useful reminder that not every security advisory needs the same reaction. OpenSSL published it on 13 August and rated it low. The issue is an unbounded memory growth condition in the incoming channel queue of an OpenSSL QUIC server listener. That sentence is technical, so here is what it means. When a QUIC listener receives valid initial packets for connection IDs it has not seen before, it can create incoming channel objects while the application is still catching up and accepting connections. In the affected versions, that queue had no effective sealing. A remote peer that sends enough of those valid packets quickly enough can push memory use upward and potentially make the listener unavailable. The important qualification is that this is not every OpenSSL deployment. The advisory affects OpenSSL 3.5, 3.6, and 4.0, because that is where the relevant QUIC server implementation exists. OpenSSL 3.4, 3.0, 1.1.1, and 1.0.2 are not affected. At the time of the advisory, OpenSSL had not issued new stable releases for this low severity issue. The fix was available in upstream commits and planned for the next releases: 4.0.2, 3.6.4, and 3.5.8. So the action here is to identify whether you operate a native OpenSSL QUIC listener at all. If you do, monitor memory behavior, use sensible network layer rate controls where appropriate, and track your distribution's package update. That is a very different response from patch all OpenSSL immediately. Security work gets better when the scope is honest. The next item needs the opposite kind of honesty. It is not a Linux kernel or core Linux vulnerability. But if you self-host the affected service on Linux, CISA says it is being actively exploited, and that changes the priority dramatically. CISA added CVE 2026-72898 to its known exploited vulnerabilities catalog on 11th August. The issue is an SQL injection vulnerability in Metabase. It is important to be precise here. This is not a Linux native CVE, and it is not a new kernel problem. But Metabase is commonly self-hosted on Linux, often in a container or virtual machine. And CISA added it because there is evidence of active exploitation. If you do not run Metabase, this is not your emergency. If you do run a public or externally reachable Metabase instance, it jumps close to the top of the list. Active exploitation is more useful than a generic severity score because it answers a different question. Are attackers already using this kind of weakness in the real world? The operational response is straightforward. Find every Metabase deployment, including appliances, containers, cloud instances, and forgotten analytics dashboards. Confirm the vendor-supported fixed version for the deployment you use. Patch it, then treat the interval before the patch as an investigation window. Review authentication events, administrator changes, database connections, and unexpected query activity. Now we can put the whole week into a sensible order. First, patch internet-facing services with realistic exposure, WordPress, and any Metabase instance affected by the active exploitation warning. Second, patch backend services that use Axios to fetch user-influenced URLs or rely on proxy controls. Third, update systemd quickly on shared or multi-user Ubuntu systems, especially where systemd homed is used. Fourth, schedule the kernel update and reboot across your Ubuntu estate. And finally, assess OpenSSL only if you actually run the affected QUIC server functionality. That ordering is not universal. It is a decision tree. A personal laptop that never runs WordPress, Axios, Metabase, or QUIC should care about the systemd and kernel updates. A public web server has the opposite order. The next step is turning that idea into a short checklist you can use without having to reread every advisory. Let's turn all of this into a practical plan. If you run an internet-facing WordPress site on Debian, confirm how that site is actually deployed and make sure it receives the WordPress fix from the path it really uses. A package update is useful only if the code serving traffic is the code you updated. If you self-host Metabase, treat the CISA KEV entry as a priority. Identify every instance, patch it through the supported vendor route, and review it for signs of activity before the update. If you run Node.js services with Axios, do not just search for the package name. Search for the behavior that makes the advisory matter. Services that fetch user-supplied URLs, follow redirects, reach internal networks, or rely on no proxy to enforce a boundary. Those are the systems worth testing first. For Ubuntu systems, update systemd promptly. Put systemd homed at the front of the queue on shared machines and on systems where multiple users can log in. Then plan the kernel rollout properly. Apply the correct meta package, account for third-party modules, reboot, and verify the running kernel. Do not allow a completed package installation to masquerade as a completed kernel update. And for OpenSSL, be selective. If you do not operate a QUIC listener on OpenSSL 3.5, 3.6, or 4.0, CVE 2026-14456 is not the fire you need to fight today. If you do, track the next packaged fix and put sensible limits around the listener while you wait. That is the useful pattern for Linux security updates. Exposure first, real deployment path second, then patch urgency. It is more reliable than chasing the scariest CVE headline across the internet. If this breakdown helped you decide what to patch first, please like the video, subscribe, and sign up at tondaslinux.com/subscribe for the weekly security update. And if you want to support the channel directly and get some cool perks, consider clicking the join button below to become a pseudo user or get root access.